In this video, we'll see what we mean by universal quantifiers. Before we get into it, let's take a predicate given by p of x, which is, say, absolute value of x greater than or equal to 0, with, let's say, universal set, the set of all real numbers. Now, for this predicate, whatever value you choose from the set of all real numbers, this remains true. Therefore, p of x is true for all x's you choose from the universal set. This can be described using universal quantifier. So, what do you mean by universal quantifier? This is kind of phrase. The phrase for every x, or you may use for all x, or for each x, x is called a universal quantifier. Universal quantifier. We use this symbol. We use this symbol to denote the universal quantifier. So universal quantifier, the universal quantifier is denoted by this symbol. As you can see, this one, the symbol is an inverted A. When mathematicians used to choose simplified forms that can be related to their original meaning for assignment of symbols, like for example in this case, for all, as you can see in this word, A, the uppercase, for all, from this we chose A to represent inverted form of A to represent universal quantifier. Thus, this statement happens to be true regardless of the choice of values from this set. Hence, we may represent such situation by, for all x, we know the predicate p of x is true, which equivalently mean, this is actually to mean for all x, where the x's are taken from the set of all real numbers, absolute value of x is greater than or equal to. So we don't need to tell what type of value that we have to choose, because this indicates we are free to choose any x. So for any x, this is true, is described by the symbol, this one. So let's take a few examples on this. In this example, we have given the universal set, which is set containing -1, 0, 1. And now this proposition, open proposition, is x squared plus 1 greater than or equal to 1. Now one can say this statement is true for all x, in this case, for all x, p of x can be said only if we know x squared plus 1 is greater than or equal to 1 for every x. For instance, if we have pick -1 here, -1 squared is 1 plus 1, and that is 2, which is greater than or equal to 1. It is true. If I pick 0, I will get 0 plus 1. Again, 1 is greater than or equal to 1, which is again true. The same is true for 1. Hence, for all x, p of x holds. This holds. Therefore, as far as p of x holds for all x, we can say this statement is true. When it comes to Q of x is absolute value of x plus 1 greater than 1. For this particular case, if I choose negative 1 in absolute value is 1. 1 plus 1 is greater than 1. That is true. If I choose 1, again I will get that statement true. But for 0 plus 1 is not greater than 1. Hence, for all x, Q of x is not true. We say so because the statement fails to be true for only one element in the universal set. Therefore, whenever you check whether a given universally quantified proposition, open proposition, is true or not, you have to make sure that it is true for every element in the universe. So if you can find or identify a single element where that open proposition fails, like in this case, then that statement is false.